Hello everyone and welcome back to a new video in our modeling, analysis and design of reinforced concrete building structures. And this is maybe the penultimate video of this series, because in this video we are going to do the ramp, and in the next video we are going to do the wind loads, and after that we are going just to show you how you design and basically provide some outputs. So without further ado, sit back, relax and enjoy the show. Now the planning of this ramp has been done in a previous video, which I will link at the top right. And in case you're wondering, we are part of a multi-part series in which we are gonna model, analyze and design the structure. I had multiple comments on this structure. For example, one of them is about the ramp, that the ramp is too small. I 100% agree, the ramp is actually too small, but I'm gonna model it anyway for educational purposes. What I would do in real life is I would talk to my architect and tell him, hey, there is no way a car could turn around in a 8 by 4 meter slab in the middle. So this needs to be modified and addressed by the architect. However, I am not going to address anything by the architect. I'm going to continue for educational purposes. So with that being said, let's dive into it. Now, we need some columns and we need to know where our ramp is going to have a slab. Our ramp is going to have a slab at the 4 by 8, and I have already a column here at 4 meters. So this is the place where it's not a landing, but it's basically the place where the car turns around. Also, the car comes down from here and turns around there, so it goes in a clockwise direction, which means I need a middle slab here, and that's what I will do. Now, I could approach it in two ways. I could make a slab like this and then release it, or I just put a slab and just connect it. I will put a slab here and I will talk about this right now. So here I have shell. The thickness here is 250. And I'll just draw me a rectangle. This is the landing, if I can call it. It's not a landing, really. I'm going to try to draw in such a way that makes the local x-axis, and I'm trying to somehow make it work. Doesn't work, right? It did not work. It doesn't look like it. So, okay, let's delete it. What just happened? Let's draw again a floor and a shell. So contour, okay, contour this time. Maybe this will work. So we have one here, and I'm just gonna try connect it correctly. Not here, down. I've had a comment telling me that the issue of snapping has been resolved in Robot 2024. That's good news. I think I should switch to Robot 2024 to continue this series. Okay, we have our slab now. Remember that the incline is going to be carried by some columns and a beam, an inclined beam. So we need some columns. For the sake of educational purposes, I will put me one extra column and that's it. So in my X, I have here, what's this X here? This X is 35.2. And this X here is 45.3, 40.2. So here 40.2. I'll add that and close. And now I have a column in the middle point of the ramp. I will make me a column. So I think my scaling is all over the place, but it doesn't matter. The column here is 700 by 700. This is a dummy column. I still have to change them during the design. And I will show you the iterative procedure I use for that design. For now, I don't have it, so I'll just continue. Here I have a column. I'll just plant me a column there. I think it worked. Yep. And here I have a column. The column, once again, back to the point of, is the column integral in the wall or not? You could just deal with it by defining a coordinate that is not touching the wall, or you could just offset the column, or like there are a million ways of dealing with it. I'll just draw the column for now. So I'll just draw the column here and click in the middle point. Can I catch that somehow? This is the X, so it should be somewhere here. There we wait. Is it the correct one? and I will just refresh the drawing and draw the column correctly. So I click on column like this. Now 700 by 700 is big. I think it should be less. I'll keep it now. So I have a column here. Now this column should extend to the next floor. I'm trying to click correctly. There we go. Let me just check. Yep. And it should extend to the next floor. Yes, I have it. Okay. And now I need an inclined beam. I need an inclined beam from the top to the bottom. So there we go. Let's click a beam. Notice now that the column and the wall see each other. And I've explained this before, like you could have the column being an integral part of the wall, and you could have the column not being an integral part of the wall. This is a decision you could do. In my case, I would argue that the column should not be a part of the wall because there is an inclined beam. This is just the thing. Others could say, no, I want the inclined beam to be integral with the wall. And some even people think that there is no need for columns and no need for an inclined beam. Like I could just cast the incline, like the slope of the car, I could cast it with parts of the wall. Now this might be a little bit hard because you would need to know exactly where to stop the wall, but that's also another way. Like there is no singular correct way. I'm open to all possible methods of construction, and it depends really on the regional settings and how you do things. So as long as it's stable, you cannot say it's wrong. So I'll draw me an inclined beam now here. There we go. I think it did not draw because the horizontal beam was on. So let me just undo this very quickly and save just in case. And now I'll unclick the horizontal beam and basically draw again. Wait, it's a steel beam. I'm not focused today, right? Reinforced concrete beam. Let's make it 300 by 500. Now there is a technical thing I want to do very quickly. You see, I put here 700 by 700, but when you draw the beam, it's 300 by 500. Now, usually the width of the column for this ramp is equalish to the width of the beam for that ramp. What I mean by this is, let me show you. If you click on 3500 and just unclick horizontal beam and connect from here to here, I had one comment mentioning that I could create a joint here or a node here by, I think, edit intersect or something, which is a cool thing I missed in a video before when I did the beam thing. So thank you very much. Now what usually happens here is that this column is not going to continue all the way up. And here in the section, what I wanted to say is I'm going to choose a column of 300 by 500 and I will show you why. It's easier for construction purposes when you have a ramp because look, this column is not going to carry the entire structure. This column is responsible for the ramp area. So it kind of is easier in construction terms to have the column width and the beam width the same. Here the column is larger because it carries the entire structure. There is a reason for that. But here, since I can make things easier for me, I should. I might even change this to have a width of 300 just for the ramp construction purposes. You see, what I'm trying to say is, you are responsible when you do your modeling. It's not just a matter of looking good. It's a matter of thinking ahead, thinking of the practical issues. Now, please notice that I'm unable to give you everything here because, practical issues are numerous and impossible to count. But this is a small thing I want to keep mentioning that, hey, you're responsible for practical issues that arise when you do your thing. Now, the crazy thing about this is I forgot to make a column here, which is kind of annoying. I need to somehow click it. So trying to click it, I am unable to touch it, it seems. No matter, I just take this and take this and copy that thing, edit, move or copy, and copy it, one copy from here to, oh, that's the problem of the snapping, right? Let me check if I somehow can, oh, there is nothing. Oh, it was just, okay, it was just a illusion. I need to make a point here. I don't need to make a point, I have a better idea. I'll go to edit, move or copy, and I use some AutoCAD skills by clicking here and in the center point, and there we go, like in AutoCAD. This also should be changed for the reasons I mentioned just now. You can just change this into a column that is smaller. Fantastic. And now we need another beam here for the ramp and so on. So I'll just take this beam, edit, edit. Now, one way of not having headache is to connect with a middle point, but I don't. So edit, edit, move or copy. And I'll copy it from here to the center point. So I'll copy it from here to the center point. There we go. And now it's flying in midair. Why is it flying in midair? Oh, yes, because of, okay, I see. Because, and now I need to be careful in doing my slab because the column is offsetted from the wall. Yes, 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 that makes sense. Now I need just to finish this thing. So, and I need to be extra careful when I do my ramp now, because now I have two pieces, one horizontal piece and one inclined piece. Let me just finish this first. There we go. Yes. And now when I do the ramp, I need to be careful that I have two pieces. Now this looks ugly, and it is, but it's just a modeling thing. No problem in that. You could, if you think this is very bad, you could just draw from here to here. Although I think I will keep it and put me a beam here. You can even put a column here if you want it, and I think I will. So let's see. Yeah, I think I will make me a column and a beam because I'm trying to think of it practical terms. So I'll just copy that and go to edit, edit, move or copy, and copy it from here to the center point here. I think that's the correct one. There we go. Now it should make sense. Yeah, now it makes sense. There we go. Now I can make me a beam here just in case, a starting beam, because usually we have a starting beam and an ending beam. So there we go. This is I sense, my error senses are tingling here, but so far I'm doing it very accurately, but I will not be surprised if I have meshing problems. This is the starting beam. Here I need a beam because I want to transfer the load of this thing to the columns. So there we go, that's a beam. I think it's working so far, yes. Now having a beam inside the wall is not really a good way of having it, so I should copy the columns here. And I can copy the columns by clicking those two things, for example, like this. By clicking those two columns, there we go. And then going to edit, edit, move or copy, and moving it from here. Let me just click correctly to here, and now they are there, right? Once again, a reminder of that there are some technical terms here. If the columns are connected to the wall or not, that's a decision you have to do. And sorry about my sound quality and just having some special circumstances, so I'm not in my usual recording spot. Okay, now here I had some comments from you that it's very hard for you to maneuver. So I'm trying to help. Now, I agree, first of all, this is a very small space to maneuver a car, and I 100% agree. But I'm trying to somehow make it easier, although I disagree with the dimensions and I should talk to my architect in that point. But I will try to make it easier by making one slope and one horizontal, just to make the turning around easier here. And I'm just trying to salvage whatever the architect gave me. Now, I don't necessarily agree with this, but it's like something that might salvage the entire issue. I'm still convinced that our colleague's comment is correct, that this is too small. And I actually mentioned that this is too small for cars to rotate around. But well, like, this is for educational purposes. So at least let me tell you what I would do to try salvage the situation. And I still think that this is unsalvageable, but we can at least try, right? So, oh, I need a column here. Did I delete it? So I just edit, move, or copy it. Edit, edit. I think I by mistake deleted it off screen. So edit, move, or copy. And I'll copy from here to here. There we go. Once again, the discussion about columns and walls and if they are connected or not. If the column is an integral part of the wall or not, that's a discussion that is ongoing, and it depends on your view for that. So, okay, I'll just draw me a beam here and continue drawing that beam, and then draw the transversal beam here, because the landing, it's not called a landing, but this horizontal place of the ramp needs to be carried somehow. So I will carry it with the beam. I don't want to carry it on the retaining wall. You could carry it on the retaining wall. Those are, once again, two possibilities that you could have. And yeah, that's it. Now I will have to do my inclined slab and my horizontal slab. And yeah, basically. So I will do it. I'm just thinking aloud how I would do it here. So many practical issues. I think, to be honest, I think that the situation with regard to the ramp is unsalvageable. And if this was a real project, I would have some really, really harsh words to say or talk to my architect. But it's for educational purposes, so I will let this one slide. I'm thinking very loud here. And I want to tell you what the weaknesses I see in this ramp so that you have an idea why I'm annoyed. The ramp, first of all, is too small. The turning area is too small. And even something else that just occurred to me is the headspace here. The clear space, you have beams that are dropping. So the clear space is much lower than what you see. If this space is 3.2, you might have a space of 2.8. This is very, very dangerous. Like, you could scratch your car and you can bump your head if you're tall enough. So it's like, I don't know, like, I'm just totally flabbergasted with regard to this ramp. I hate it, to be honest. But I'm just going to model it anyway to show you this for educational purposes. So I modeled the first ramp. I know what the problem is. The problem is that the ramp doesn't answer the question, how am I going to go down the next floor, the next story? It's kind of really weak. I wish I had the drawing in front of me. However, I am working on an alternative computer. I told I have a small little personal emergency that I have to attend to, so I am unable to work on my usual working spot, and that's why I'm sounding different this time and having limited technology in my hands. But okay, that's that. Now here, I think this is a dangerous thing, and that's what I was annoyed about, because like, how are you going to go down here, right? So I don't know, like, I have no answer for that. What I'm thinking about is, when you go down again, usually the ramp is parallel. So how are you going to make a parallel ramp? You should go down here. How are you going to go down here if a car needs to go inside? This is garbage. Like, I have nothing, I have no words here. I cannot even salvage that. At least I will try. So at least I can only try. Okay, at least I will make the first ramp, and I will let your imagination the second ramp. I think this is a lost case. The ramp it's not unmodelable. The modeling of the ramp is not the problem. I'm thinking of the practical issues with regard to the ramp. Like, if you look here, the ramp is just too small. I don't have enough space. I just don't have enough space to model the ramp. That's it. It's as simple as that. And it's really annoying to me that it has to come to this. I think I will flip the ramp. I think I will let the ramp go from here down and then turn around horizontally and then go down and then turn around. Yeah, this is a little bit better. I'm going to flip the ramp and let him go down like this and rotate. So at least here, he just can turn right instead of going below the ramp. Yeah, I think this makes more sense. I will speed up for the second try. You can look at it. So I think that this first try with the ramp going counterclockwise doesn't seem to work. I've told you different aspects of why it doesn't work. Now, what I will do, because I already gave you my commentary, what I will do is I will redraw the ramp with silent commentary. So I will speed up the video. My video editor is going to do that. And I'm going to redraw the ramp, taking it counterclockwise. Because you see, if you go clockwise, the car must go below the ramp, which will cause problems in the headspace, and also will cause problems with the ramp in the second floor, because you have to take part of the horizontal distance as your bridge inside the building. If I make it counterclockwise, it would be a little bit easier because the car would enter here, go down half, and then turn right into the building or turn left into another ramp. So now please notice that this shouldn't have happened. The ramp is just too small, and I'm trying my best to make sense of it and to draw it in a sensible way for you. This is a nightmare. I think this is the worst nightmare I had so far. And in real life, I would just go to the architect and tell him, hey, your entire ramp needs to be rethought about. Like, you need to think about your ramp again. Now, it's not a real project, it's for educational purposes. So I will have to redraw it. So what I will do is I will redraw it very quickly, going counterclockwise with limited commentary, and we'll see how that goes on. At the end then, I will finish my video later. So enjoy the last segment of the video while it lasts, because at the end of it, I will just give my outro and video adieu. So sit back and enjoy the quick rundown and the quick modeling of the ramp without commentary. Thank you. Okay, we are back to talking now. And the final step we need to do is to apply the loads. So I will select those things. You can see it's 1276 to 1283. I will use this information to go to my load table and copy the loads on the car ramp. So I'll go to the dead load, copy it, paste it, and then change this, which is the target, to be, I need to be able to select it, give me a sec. There you go. I'll just delete everything here. It's a long list, by the way. And I'll write here 1267 to 1283, and Robot understands this. So there we go. 1267 or 76. Let me just check very quickly. 1275, yes, not 76. 127. Let me just check very quickly. Yes, 1275, my bad. 1275, great. So we go to loads again to continue our load definition, this time copying the live loads. I'll go here, or I can just copy the dead load and use it to define the live load by going here, selecting the case, if I'm able, live load, and the load is 4.79. So if I go here and select the load case, check, there should be loads on it. Let me see very quickly. And yep, it's loaded. Fantastic. Great. All right, so I'll finalize this very quickly. I'll add a slab here. The architecture doesn't say there is a slab, but I think there should be. So I'll add me a quick slab. All right, that was a ride. At least I tried in this video to model the RAM to best of my knowledge, to best of my understanding. Of course, we pointed out the problems in the RAM, and I had a previous video where I explained how usual ramps are, but I tried to stick with the sense of the architectural drawings I have. Although in real life, I would immediately go to the architect, talk to him, explain to him that he should change or increase the size of the ramp or find a solution for that. The solution, at least I have done, is I tried my best to somehow fit in a ramp here. In this case, I have made the car go onto the right, go counterclockwise, and be able to go below the ramp. And this is how I would do it. Of course, you can enter the story from this side. So I think this is like as good as it gets. Also, the architect totally forgot to give a slab on top of the car ramp, so I have done one here. One very important detail you need to understand in car ramps is that here you need some sewage system, some stormwater drainage system, because when it rains, of course, the water will seep through the ramp, and you need here a water collection system. This, of course, is not part of my series because I want to deal with the structural aspects of that. Now, with that being said, I am not really particularly proud of what I have done here. At least I want to show you how to model it. Of course, you would have more space to do that, not like me. Just a small information here. What I have done, I drive a Kia Sorento. It's a mid-sized SUV. And I tried really to test this. Like, I basically went to a sandy place and I drove in a circle. I wanted to see the turning radius of that Kia Sorento. It turns out it is really a challenge to turn in a space of like 4 meters by 8. It's really a challenge to make a half circle here. I was able to do it once, but of course, on a sandy place, you don't have the psychological issue of being worried to hit the column. So on a sandy place, you can see that the turning cycle is just about right. Of course, in a structure, you will not be able to do this, so I don't think this will work. I think somebody could just turn left and back up a little bit and turn again. This is a nightmare, but well, it is what it is. So yeah, that's everything I wanted to talk about today. I hope that you enjoyed the video. And of course, before I finish, I want to give a huge, strangely sized shout out to my dear channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as the support of the channel is priceless to me and enables me to provide you with videos on time. Oh, that's a problem. And with a certain quality I try to achieve, and for that I am forever thankful. Of course, as usual, I hope that you enjoyed the video and you found it beneficial. If you have found it beneficial, then please consider liking, sharing, subscribing, and so on, especially subscribing, because it helps increase the reach of my channel. And as per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video.